Hello and welcome to the second tutorial for the virtual Sikorsky S-92 for X-Plane. Today we'll review some more of the buttons, switches, and levers that you might find in the cockpit and cabin. We'll also practice ditching in the water. Thank you to everyone so far who has posted either a comment or requested a topic to cover. And by all means, if you have any more questions or comments or feedback, please feel free to post it in the comments section. And at this point, let's get to the tutorial. So a few people have contacted me with questions about how to open the doors. You might have seen in some of the videos that the cabin doors, whether it's the sliding door that you might find in the search and rescue model or the Cyclone, the CH-148, or the doors that open upward and have an air stair on the bottom, those are both linked to the flap data reference that X-Plane uses. So what you can do is if you have a flap button assigned to your keyboard, to your flight control stick, your yoke, whatever it is you're using, you can use that to basically trigger the flaps, and that will open the door. Or you can actually enter the 3D cockpit and sort of navigate your way back to either the interior cabin or outside of the cabin and actually roll the mouse over the handle, click it, and it will open. Because the door is linked to the flap data reference, it requires power because X-Plane thinks, currently, X-Plane 9 at least, thinks that all flaps require electricity. So if you've noticed that your doors don't open for some reason, it's most likely because the power is off. Another handle that you can click on is the lavatory. If you're in the VIP or the VH92 variant, then there is a lavatory. You might have noticed a door that's sort of behind the cockpit and directly in front of you if you're entering the cabin through the main door. If you click on that, a door will open and you'll see that there's a lavatory inside, and click it again and the door will close. Another one of the most often used doors, if you could call it that, would be the cargo ramp. So to actually operate that and raise it up and down, there's a switch in the cockpit on the overhead panel, which is in the hydraulics section, and the switch is labeled ramp up or down. So if you toggle it to down and there's power pressurizing the hydraulic system, then the ramp will come down, and if you toggle it to up, the ramp will come up. Another question that came up was about the various liveries that you might have seen in one of the previous videos. So for example, the CH-148, the Canadian Armed Forces livery, that only works if you open the CH-148. So it won't be something that you can select on the livery list. The same applies to the VH-92. If you want it to look like Marine One and say United States of America on the side and be painted green with the white top, that's just the default paint scheme of the VH-92. It's not something that you can apply to the other models or the other variants. So there are more liveries available than appear on the list, and those are the default paint schemes for the different models and the different variants. So moving on to actual flying operations, we're going to discuss now the process of ditching in the water. And I've gotten some questions and comments from people who have tried this and discovered that the helicopter wants to roll over when you hit the water, which is a common problem in X-Plane and in real life too, I guess. Helicopters are top heavy because all of the heavy components like the engines and the gearbox and the rotor system, the rotor mast, and all the different actuators that move the pitch ties and the swash plate and all that is basically piled on top of the roof of the cabin. And so it's very heavy, and if you land with side loads or in water where the sea state is really high, then chances are you'll probably roll over, which I guess would happen in real life too. So the easiest way to not roll over is to lower the sea state. Make that wave height, set that down to 0, somewhere between 0 and 1. You want to try to reduce the effect of the choppy water as much as you can. And you also want to try to cushion your landing and stay coordinated with your flight path as much as you can to just reduce side loads as much as you can. Because if it's going to roll over, it's most likely going to roll over along the longitudinal axis. So now let's just try to imagine for a moment or come up with some reasons why you might need to ditch your aircraft in the water. The most obvious thing, I guess, would be a complete power loss, or a power loss where you lose enough engine performance that you can no longer sustain your flight. Another reason might be an oil problem. If you're losing oil pressure, or the temperature indicator goes off saying your oil temperature is too high, that's a serious problem. If there's a platform nearby or you're close enough to shore, then you could aim for shore, and hopefully you get there with time enough to spare where you still have engine power, and before all these things like the gearbox and engine start coming apart and possibly seizing up and stopping the drive shaft to your tail rotor, for example, or even stopping the main rotor system. And the helicopter doesn't fly very well if the rotors stop spinning. Another cause for ditching might be a tail rotor failure. So if you have a fuel state that wouldn't allow you to get back to land where you can safely make a run-on landing in a field or on a runway or something, then there's pretty much no chance that you'd ever safely, successfully land on the platform without a tail rotor. So that might be another reason that you decide to go into the water. I guess I could go on and on, but these are really the main things, at least that I was able to come up with, that might be cause or reason enough to ditch the aircraft and the water. And these are things you could practice using the failures option within the simulator. You can set up some of these systems to fail so that you could actually practice doing this in a way where you can set it up where some certain amount of time might go by, or an unknown amount of time might go by, and one of these systems might go down, or you can set it up to fail on your command as well if you want to practice this in a way that you can control. That's really up to you. But so back to the actual process of ditching in the water. If you have a power loss, what you'll be doing essentially is entering an auto-rotation. We just happen to be over the water, but the same principles apply if you were doing this over land. As soon as you recognize that there is a power loss and that your rotor RPM is dropping, you need to unload the rotor disc by lowering the collective. And what that's going to do for you is reverse the airflow. So rather than having the air flowing through the top of the rotor disc downwards, the airflow is now going to reverse itself so that it's moving up through the rotor system. And that airflow is what's going to keep those rotor blades spinning, basically, instead of the engines. The trade-off is that really you're just exchanging your potential energy into rotor RPM. You need to be giving up altitude in order to keep your rotor blades spinning. Really, the whole auto rotation process is all just a prelude to what happens at the end. Your goal, obviously, is to land as softly as you can at the bottom. So you want to keep the rotor RPMs in the green. That's the first step. As soon as you see that needle is dropping, you need to get the collective down to the floor and get that needle to move back up into the green arc. If you let the rotor RPM drop too far and the blades slow down to a point where they cone beyond the flex limit of the spars and the blades, then that's game over. So you really need to keep those RPMs up and in the green. That's really the first priority. Now, just like in a fixed wing plane, the higher that you are, the more time you'll have. So if you're cruising along at 10,000 feet, you'll be auto-rotating a long time, not necessarily doing anything. I guess you could be trying to restart the engines or troubleshooting whatever the problem is, but I mean, as far as the flight control inputs, once you have that set, it's just a matter of, you know, keeping the rotor RPMs where they should be and steering where you need to go. And I mean, that's basically it for a while. I guess I sort of glanced over the fact that during your auto rotation, you want to maintain forward airspeed, maybe about somewhere between 70 and 80 knots. And that airspeed will come into play in a very important way when we reach the bottom. So we're in our auto-rotative descent. Now, once our airspeed is stabilized closer to about 75 knots, maybe 80 knots or so, we can deploy the floats, which are essentially big cylinders of air. They're like airbags that are made out of the same material that a life raft is made out of. And compressed air canisters fill them up really quickly when you push this button, and that volume of water, which will be displaced by these huge bags of air, is what's going to keep the aircraft afloat once we're actually down to the water. At about 150 feet or so, you want to begin pulling back on the cyclic and adding a little bit of pitch to the collective, so pulling up on the collective. What that's going to do for you is change your vector from being one that is descending to being one that is level. And so this is where that airspeed is going to pay off. That forward airspeed is going to be what continues to spin the blades while you stop descending. Now, as you slow down, the force of the relative wind moving through the rotor system unfortunately slows down as well. So this is it. That is all that was keeping your rotor spinning, and now it's gone, or it's below a point at which it's useful. It can't keep the blades spinning as fast as you need them to anymore. So it's at this moment in particular that you'll begin to see how difficult this is to do, especially in an S-92. The aircraft is so large and so long that when you're in the flare, you're at a pretty dramatic angle of attack. And you can't forget that the aircraft's about 60 feet long. So where you're seated in the cockpit, you're going to be a lot higher above the water, in this case, or the ground if you're doing this on land, than the tail rotor is. And you don't want the tail rotor or any rotor to be the first thing that touches down. And ideally, you don't want it to ever touch down. So what we need to do is, as soon as we recognize that our rotor RPM is beginning to dwindle, we need to pitch forward. We need to level out so that we're more or less parallel with the ground. You want the belly of the fuselage, and in our case, the floats, to be what touches the water first. And in an S-92, that's going to mean that we still have some forward airspeed. If we were doing this in a lighter helicopter, like an R-44 or a Bell Jet Ranger, we could actually have enough inertia in the blades that we could bring ourselves to a complete stop, a hover more or less, as we cushion our landing and touchdown. But in an S-92, it just doesn't really work that way. We're so heavy that it's just, we don't have as much leeway to do it the way that we could in a smaller helicopter. And I'll include a link to a video of an actual S-92 doing an auto rotation, and you can see the difference. That'll probably be more effective at explaining and showing you what I mean than me droning on verbally about it. So check that out, and you'll see that there's a point at which they're still moving forward through the air relatively quickly, but they nose over because their RPMs are starting to drop. So a big pitfall to avoid is trying to flare yourself to a point where you have 0 knots forward airspeed. that probably won't happen. And if you try to do that, you will most likely impact the tail into the ground or the water. One of the other main key points of the flare is that you don't want to balloon upwards, meaning you don't want to gain altitude while you're flaring. You don't want to pull so much pitch with the collective that you begin to gain altitude, because all that's going to do is leave you higher with less rotor inertia in the end. You want to stay as low as is safely possible while keeping the rotor RPM as high as possible within its limits, because that rotor RPM is what's going to allow you to make the final changes and adjustments and provide you with the lift that you need to make the landing as smooth and as good as it possibly can be. Now, if I can use an American football analogy here, this whole thing is kind of like the last drive, and we're the team that's down on points, so we need to get down the field and score before time expires and the game is over. And the flare is kind of like the second to last play that we can make. So what we want to do is just set ourselves up to have the greatest possible odds of success in what little time is going to remain on our last play. Because remember, when you're flaring, you're going to hit that point where the airspeed drops off below a point that it's enough to keep the rotor spinning. So that's kind of like our stopwatch. And once that watch starts running, or that clock starts running, there's a finite amount of time in which you're going to have usable lift in your rotors. And the amount of things that you can do is going to be diminished. So going back to this football analogy, if you're within 10 yards of the goal line, there's a lot more that you can do with the time that you have left, and your odds of success are much higher than they would be if you were all the way back at the 50-yard line. And I apologize if you don't watch American football or understand how the field is laid out. That's really the best analogy I can think of, is the flare is really trying to put yourself in the best position you can be, because there's going to be a clock that's about to start that's counting down to the end of the game, and you, and especially your passengers, really want to win this game. You really want to survive this landing. So when we reach the point where we're cushioning the landing, we're feathering it with every last remaining bit of lift that we can draw out of the rotor system. You don't want to waste any lift or inertia lingering at a relatively high altitude. So when you complete the flare and you pitch over, hopefully you're somewhere around maybe 30 or even 40 feet above the ground, and you need to let yourself descend. If you start trying to soften your descent too much too soon and just linger at 40 feet, for example, eventually you're going to run out of collective travel and lift, and you're just going to drop from 40 feet to zero and basically a free fall. So you really need to practice how much collective to apply when. You want to apply the most of it at the bottom. So it's really a lot like landing in a fixed wing aircraft. You don't want to flare so high above the ground with the engine pulled back to idle that you stall at 50 feet and then just nosedive into the runway. You want that stall, when you hear the stall warning horn go off and the wings bleed off whatever lift they have left. You want that to occur, at maybe 1 foot above the ground, so that you then softly, the wheels touch down. It's really kind of the same thing here. You have a finite amount of lift left and a finite amount of collective travel left. So you want to make sure it runs out when you're basically somewhere between 0 and 1 foot off the ground. That's really it, though. And you'll learn a lot more, I think, by doing it, even if it means crashing 10 times or 100 times. That's really the value of doing this in a simulator. It's like you can see what happens without any threat to your life and your health. So it's really the best way and the fastest way, as long as you understand the basic principles, is to just try it, and maybe even just try different things. Maybe even intentionally try to not do it perfectly, just to see what what happens and how it happens. So, I mean, that's just something to consider. And really the last thing, because I'm going to try to separate the following tutorials into their own tutorials. We're going to cover landing on the ships like the frigate and the aircraft carrier, and then also landing on the oil platforms. So I think we'll sort of leave this tutorial at ditching in the water / auto rotation procedures. So the only other twist, I guess, on ditching in the water would be if you were to do it under power. So for example, you have a fuel leak and the whole helicopter is on fire and you need to land, but there's still torque from the engines. And in this case, unlike doing an auto rotation, you just have more power, so you can control the landing. You can enter a full hover and touch down with 0 forward airspeed at the most gentle descent rate imaginable or possible. The next step would be, in theory, you've initiated your ELT, so that's going off and transmitting your position. And if you squawked the emergency code on your transponder, then that would have alerted air traffic controllers that something's wrong. And then, in theory, people are coming to look for you. And if you climb out into the life rafts, it's far more stable on the water than this helicopter is. And that would be it. Eventually, someone would come and rescue you, and all would be well and good again in the world, unless you were the mechanic who has to try to deal with the helicopter that's now saturated in salt water or whatever water. I'm just babbling. But anyways, that's this tutorial, and more are coming. We're going to do the ships, we're going to do the oil platforms, and if you have any more ideas or any more requests, go ahead and let me know, and I'll see you on the next one.